Hello everyone, this is Dr. Webb and welcome to this calculus video. Over the last couple of videos we have been looking at derivative rules, and so this is a recap of what we've seen so far. So first, if you take the derivative of a constant times a function, it's just going to be a constant times the derivative, so we can pull constants out. If we're taking the derivative of a sum, then it becomes a sum of derivatives. That isn't true with products, though. And so in the product rule, we saw that if you want to take the derivative of two functions multiplied together, then that's going to equal the derivative of the first function times the second, plus the first function times the derivative of the second. And then we use that to look at the power rule, which tells us how to take derivatives of powers of x. And so we were looking specifically at integer powers so far, and in that case, when you take the derivative of x to the n, it equals n times x to the n minus 1, so the power comes down, and your new power is the old power subtracted by 1. And then lastly, we saw the chain rule, which is what happens when you're taking the derivative of a composition of functions. And so if you have g of x inside of f of x, so g of x is our inside function, f of x is our outside function. When we take the derivative of that, it's going to be the derivative of the outside with the inside function plugged in, and then multiplied by the derivative of the inside. So our focus for this video is how can we take derivatives of quotients of functions. So this is where we're taking the derivative of where we have one function divided by another function. And we could go about proving this very similar to how we did the product rule using the limit definition, but I think it's a little bit more illuminating to see this as a particular case of the chain rule and the product rule working together. And so this is what I mean. So let's start off with a simple case. So in this case, the numerator function is just 1. So we're just taking the derivative of 1 over g of x. And instead of thinking about it as 1 divided by g of x, we can think about it as being g of x raised to the minus 1 power. So we're taking the derivative of g of x raised to the minus 1. Now, thinking about it this way, this is something that we can apply the chain rule to. So we're going to apply the chain rule here. And so we have to think about what our outside function is and what our inside function is. So our outside function, what's happening to g of x? Well, it's being raised to the minus 1 power. So our outside function is x to the minus 1. Our inside function is just g of x. And then we know how to take derivatives of both of these. So x to the minus 1, this is something we can apply the power rule to. So the minus 1 comes down, and we'd have x, and then we take the power away, reduce the power by 1, so it would be minus 1 times x to the minus 2, which is just a fancy way of writing minus x to the minus 2. And for the derivative of the inside, well, since the inside is g of x, its derivative is, we'll just say, is g prime. Okay, and so now we can apply the chain rule here. And so this is going to be derivative of the outside with the inside plugged in times the derivative of the inside. So our derivative of the outside is minus x to the minus 2, and we can plug the inside in there, just g of x, and then multiplied by the derivative of the inside, which is g prime of x. So let's clean this. There we are. And then as you can see, we also, since we have a negative exponent here, we can move that back into the denominator. And so this is equal to minus the derivative of g divided by g of x squared. So the original g squared. Okay, and so this is coming just from using the chain rule and the fact that we know the derivative of 1 over x. Well, so how is this now going to help us approach the derivative of f of x over g of x? And the idea is that we can think about this as being the derivative of f of x times g of x raised to the minus 1. And so f of x is the function. We're assuming we can take its derivative, and g of x to the minus 1, we just took that derivative, and so we know how to do that. And so now this is something that we can apply the product rule to. So there it is, written nicely. We're going to apply the product rule here. So our first function is f of x. So let's call this u, let's call this v. So our first function u is f of x. Our second function v is g of x to the minus 1. So the derivative of u is just f prime. And then the derivative of v, which we just figured out on the last slide, is going to be minus g prime of x over g of x squared. Okay? And so now we can set this equal to, so the product rule says this is going to be u prime v plus uv prime. So u prime is f prime of x times v is g of x to the minus 1 plus u is f of x times v prime minus g prime of x over g of x squared. And so we can clean this up a little bit. There we are, all nice and cleaned up. So again, that's our derivative of u. There's our v, there's our u, and then our v prime is all of this and incorporating the minus sign into that, coming from the product rule. And so we can convert these back into fractions. So let's do that. So f prime of x over g of x minus f of x times g prime of x over g of x squared. And so this is a perfectly fine way of thinking about the quotient rule. But usually, since the denominators are g of x and g of x squared, we actually can combine it into a single fraction by taking the first term and multiplying the top and the bottom by g of x. And so then we can combine it, and we get this, just sort of thought of as the traditional form of the quotient rule. So here is our quotient rule. So the quotient rule is when you're taking the derivative of f of x over g of x, it's going to be f prime, so the derivative of the top times the bottom, minus the top times the derivative of the bottom, divided by the bottom squared. Okay, and so here it is again. The derivative of f of x over g of x is equal to the derivative of the top times the bottom minus the top times the derivative of the bottom, all divided by g of x squared. And so the important thing to remember in this quotient rule is that the quotient rule has a negative sign, has a subtraction between these terms here, and that it's g prime is getting subtracted away. And this is coming from the derivative of 1 over g of x makes it negative, tosses in a negative sign into there. So that negative sign gets tossed in right there. So this is one of the big main differences, main things to remember about the quotient rule, different from the product rule. Product rule, it has an addition in between it. The quotient rule has subtraction. Okay, so let's finish this video off with an example. So we're going to take the derivative of x plus 3 divided by x squared minus 1. And so our top function here, let's call it f, is x plus 3. Our bottom function is x squared minus 1. And then the derivative of the top, the derivative of x plus 3, is just going to be 1. Derivative of the bottom is going to be 2x. The minus 1 just goes to 0. And so now we have all the parts that we need. So applying the quotient rule, I can just follow this from above. So it is f prime times g. So this would be 1 times x squared minus 1 minus f times g prime. So let's write these in. X plus 3, that's my f, times g prime, which is 2x. And then at the end, we're dividing by g of x squared. So x squared minus 1 squared. Okay, and so there it is. Let's write it out nicely so you can see this is our g. F prime is equal to 1. And then we have a minus x plus 3, that's our f. 2x was our g prime. And then on the bottom, we have g squared. And if you want to simplify this, if you feel so inclined, your aesthetics demand it, you could expand this out, and this is the answer you would get. Okay. That is all for this video. I think it was pretty short and sweet. I will see you again soon.